All right, we're back. We are COMP305, and it's the fall 2017 semester at Centennial, and we are week 3, part 1 of our broadcast. I was going to do presentations this morning first, but lots of people are late. So we're going to start just with the Unity demo first, and then we'll move into our presentations for the people who are here in groups. Again, today we're going to be presenting our game pitch. So I'm hoping to see some really good ones, right? Some, and I will give you some feedback. I'll also put up a Dropbox up on East Centennial so that you can hand in your presentation document required today. All right, so that'll be due by the end of day, like today midnight. I'll probably make it up so that if you have to, any feedback you get today from your presentation, then you'll put it up in your, you can kind of hold up in your document and submit it tonight. It is worth 5% of your grade, so if you don't submit tonight, then that would be bad. Let's go into COMP305 last time with the mail pilot demo. I've given you the, last week I gave you some assets, and we talked about some player movement, very, very basic. And there was an issue we ran into with you know, using the mouse to move our player on the screen, and part of it, I love this, these little updates here. Part of it was that we did a couple things, right? We had our player that we made. Let's review a little bit. All right, so here's our sprites. And notice what we did here with our plane sprite is we made it pixels per unit. We changed to 1. That's what we did. We also, if you scroll down, we also made our compression none, right? And our filter mode point no filter. And the reason for these things is we want pixel perfect sprites on the screen, number 1. And the second reason for this is we want there to be no pixelation, if you will, right? That will happen if you use some of these values. Now, you guys have learned in the past that there was the, you know, you've used sprites that are 100 to 1, and that's when you use the game mode that is showing aspect, right? We're not doing that kind of game. We're making a pixel perfect game. So absolute positioning is what we're using. It's great for learning how to do 2D stuff, right? But when it comes to, you know, being responsive and putting your game on different devices, this is not the only way to do it. And if you're going to do something like this, you would programmatically somehow make it adaptive on your own. But we got this game, and if you remember last week, what we did was, right now there's not much of a game. All we can do is move our player left and right. Have up online, we're using a GitHub repo from last week. And we're in GitHub so we can see it, which is this one. COMP305 F2017 mail pilot demo. This is the one we were doing for this one. We're going to continue with this one because I want to build up the demo so I can show you everything from enemies, how to do enemies with Unity. So please follow me here and slow me down if you can if I'm going too quickly, because I want you to get some of this stuff, right? For those people who are doing kind of shooter games, this is a good primer for you. To get going, and especially if you've never done a game before. Some of you are not game students, so it's a good opportunity for you to see how to do stuff if you're not a game student. We use Unity a lot of times in the real world as prototypes, right? So we make a Unity prototype because it's quick. If I was going to make the same game that I'm making now with OpenGL, it would take me a lot longer. C++ and OpenGL, raw, man, this would take me a while to get together. But I can slap this together. I'm telling you like how it is, a little baby game like this, right? In 10 minutes, right? So that's really, really good. You can kind of, we use Unity a lot of times to find the fun in our games, right? So we kind of put stuff together, prototype it, see if it's fun. If it is, then we make our real game, let's say with OpenGL and C++, which takes a lot longer to do. All right, so here we are. We've got this. Hopefully you guys can all hear me, by the way. So I'm not using my speaker. I totally forgot to pull this puppy out right here. So we've got this game, and I want to put the background in place. Okay, so we've got the plane, and the background that I'm going to use is this ocean background. Okay, so if we actually were to look at the the files online. So if I go to my desktop and I want to go and see where my my folders are for my Unity projects, right? So projects, and I'm looking at this one. You can see that inside my folder structure for my Mail Pilot demo, I have the assets, right? Inside my assets, I can have my sprites. This is how your folders look like, right? And you can see that I have an ocean.gif or GIF image. That people say it differently. This is not a PNG image, so it's not. There's no transparency. It doesn't preserve transparencies with different kinds of image formats, right? But here's the great thing. Take a look. It's 588K. It's not very big, right? This little ocean GIF, right? So I'm going to double click it for a second to open it up with Fireworks, just so you can see what this engine, this ocean looks like, right? So it is, if I click onto it, 640 wide. So obviously it's been engineered for a 640 40 pixel wide game. If you're going to make some kind of scrolling background, and that's what I'm showing you right now, a scrolling background that's for a wider game, then you have to change the background. Please don't programmatically scale anything in your game if you can avoid it. And just curious for people who, you know, I want to see some people trying to understand this. So why wouldn't I want to scale programmatically my stuff in Unity, like all my assets? Can anyone think of why? I don't want to scale it with code. I want to scale it beforehand, and before runtime hits, I want everything scaled ahead of time. Why? Can anyone think? There's no processing time, right? The less processing time we have, the more performant our game is, right? So we have scaling and all that stuff coming, then our games are less performant, right? That's what ends up happening, and it has nothing to do with you know, our good code or whatever. It has to do with the fact that your game engine has to scale pretty much and maintain that inside of your, you know, frame by frame. It has to redraw this rescaled item over and over again, right? So we don't want that. We want to make assets or pick assets that are to scale with our game ahead of time. Okay, so this is the problem. So we've got 640K or 640 pixels this way, and down this way we have 1440 pixels. So this is going to scroll up and down. If we can imagine a screen, a viewport for the player, all right? If I can imagine a viewport for the player, and let's just make this viewport, make it transparent for a second. So we won't choose a color, and we'll give it a bit of a border, right? So let's make the viewport a border of, let's say, 5. So you can see the viewport, and we'll make it 640 by 480, just to match the viewport that we have right now in our Unity game, right? So 480, there we go. And if we move this around, right? So let's first, I'm going to lock the layer so I can't touch my background, right? But let's just move this around. So I'm going to move this layer around. If I can just do this properly, undo. Here's if I can do this properly. So there's my layer, and let's say, for example, it starts here, right? If I was to zoom in, so here's where I normally end. So maybe the game is going to start looking like this. So this is my screen. Part of my ocean, right, is off screen. So question like I have again for you guys, is the ocean, the parts that's off the screen, is it part of my game? Yeah, because even though it's not being rendered is a fancy word for drawn, being drawn to my screen right now, it's still contained inside my game, right? So what I want to do is I want to start the ocean here, where the bottom of the ocean and the bottom of my screen are the same. And then what's going to happen is the ocean is going to scroll. Let me just move the ocean now. The ocean is going to scroll down like this at a certain rate of speed, right? So there's my speed of the ocean. It's going to come down like this, right? And then when the top of the ocean hits the top of my screen, I want it to reset. So I want it to go back up to the top, right? And it's going to keep on doing this, right? It's going to continue to scroll and reset and scroll and reset to simulate me going through an endless ocean, okay? Now, here's some things to note about this ocean graphic. One, it kind of looks the same on both sides. So you're probably not going to be able to tell a lot of differences. The edges on the bottom of the ocean and the edges, this is really, really important, on the top of the ocean should not be that different. Otherwise, you'll see that there's going to be an edge here that'll be very apparent when you kind of go down and it's kind of come up really, really quickly. Almost like it'll look like there's a severe cut right? Now this ocean graphic's not bad. There are better ones where you don't see, it's actually tiled. So the actual graphic will be tiled on both sides. So that way it looks like it's just one continuous flow. It doesn't look like there's a cut from one side, the one side of the ocean to the other. But I've used this many, many times, so I know it's going to work. So that's what the ocean graphic's going to do. So it's going to start all the way here. But notice if I put it this way, and if the bottom of my ocean graphic is here, and if we assume that the top left corner of my ocean graphic is the 0, 0 point from a local coordinate space, right? Each object has its own coordinate space, right? And if the top left corner of the ocean is where we start to draw the ocean, right? That means it's going to be a negative value off the screen somewhere, right? Some negative value. So that's how it's going to work. Let's bring it back into Unity. I'm going to drag and drop my ocean graphic. Here's my ocean graphic. I want to drag and drop it onto the screen. Let's do this together, guys. Please don't watch me. Please do, or else you'll never get this. All right, so here's my ocean graphic, and right now, by default, you can see that here's my viewport in Unity, just like I talked about in Fireworks, right? And you can see that the ocean is right in the middle. I don't want to start my ocean here. I want to start my ocean here, right? I want to start up here. Notice that the Y value of the ocean is 481, right? If I move it down, you can see that it's going to go back down to 0. There's 0. There's the 0 point, right? Okay, so 481 is where it's going to be, right? And if we want to really be specific and see where the bottom of the ocean is, because we want to make it so that the bottom of the viewport and the bottom of the ocean match, right? So you can see that if I look at it, let's make it to 481. Let's see what that looks like. So 481. And you can see that even if I zoom in even more, and it's good to zoom, so you can see if there's going to be any defects in your game. You can see that way at the bottom be a little space. Look at this little space here. And you're like, who cares, Tom? No one's going to see that. Yeah, they will. Because if you don't go pixel perfect down here, because they're using pixel perfect graphics, what's going to happen is there's going to be a line that appears on the bottom of your ocean or the top of your ocean at some point when it's scrolling and repeating. Okay? So I want to move this down a little bit more, and I can nudge it down. There's a couple ways. I can use, if I hover over the Y coordinate, I can actually move, the Y like numerically like this by just actually kind of moving my my cursor left and right until I can see that it's almost perfect, I would say. So it's like, it's pretty close. And you can see that 480 might be a better measure. So 480 would be the right place to put my ocean. And actually, it makes sense. Why does it make sense that it's 480? Even if I didn't have to do this like exactly by my eye, I can do it numerically because of my graphic. The graphic is 640 by 1440. And if I think about it, and if I say 1440, right, and if I divide that by 480, right, you can see that there's 3 screens of ocean, exactly 3 screens of ocean. So it should be, because I have 480, my screen height is 480, right? And if I want to have 3 screens of ocean, then I want to move it on a factor of 480. And it's, in this particular case for Unity, it's exactly 480. So I want to start my ocean every time at 480. Okay, good, that's good. Now, what do you think, if this is where my ocean starts, and I want this ocean to flow down from the top, I want the top to meet the top of my my viewport, what do you think it would be when the top hits the top of my viewport? Anyone think? Well, let's see. So if I move it down here like this, take a look at the Y coordinate on the space. So 480 is where I want it to start. But it's going to come down to the point where it's negative 480, right? So if I go negative 480 here, and you can see that if I zoom in, this is good to understand symmetry and how Unity does things. That's why I'm showing you this stuff, guys. So if I go right in here, you can see that it's exactly on the edge of my viewport. There it is. So look at my viewport. It's perfect, right? So negative 480 and 480, and because, not because I'm perfect, but because the ocean graphic has been made perfectly. So there's 3 screens. worth, right? It's exactly pixel perfect. I'm using pixel perfect camera coordinates and a perspective view, sorry, an orthographic view, right? So it's going to work out. So it's going to go from 480 to negative 480, or negative 480 to 480. And it's going to keep repeating over and over again, right? Okay, this is the key. Let's put it back to 480 because this is where I want to start. Yay, I got my ocean graphic. Let's rename the ocean graphic with a capital O because I want all my graphics to appear this way. There's another problem. Okay, we got our player, but where the heck is my player now? Because I put my layer, my ocean there, right? And my player, he's gone, right? Even if I move my player below my ocean like this, it doesn't matter. I don't see my player. How come I don't see my player anymore? Yeah.
The ocean layer on top of the player.
It's the same area. It's exactly the same layer, right? It's almost like I've put both graphics at once, and Unity's trying to figure out which one I want to see first. By default, all graphics share the same layer, and if you notice inside our sprite renderer, we can see that there is this order in layer 0, right? And here's my ocean, or also order in layer 0, right? So what we want to do with my player graphic is make it one layer up or more. Instead of order in layer 0, let's move this to order in layer 1. And you can see now that the plane appears on my screen, right? So 1 is a higher number than 0, so it'll appear above the ocean, right? And if I scroll down, by the way, we're going to change that again. 1 is not going to be the final number. Right? But if you look now, you can see that the ocean, my graphic here is on top of the ocean. Now, this is what it would look like if we just played it right now. If I just play this thing without moving the ocean, you can see that my player is on top of the ocean, but the ocean is not moving, right? All right, in order for me to make anything move in Unity, right, I need some little script that I need to attach to this thing, okay? That's just very simple. So let's attach a new script to my ocean object. I'm going to add component. I'll do it this way today. And I'm going to scroll down until I see new script. This ocean controller. Press enter. There's my ocean controller script. Now the problem with doing it this way, and that's why I don't prefer it, is where the heck is this ocean controller, right? Well, it's right here in the outside of all the folders under assets. If I can make this bigger for you so you can see that the ocean script is outside the folders, and I want to organize my folders properly. So right now I want to take the ocean controller and I want to drag and drop it into my scripts folder. So my scripts folder will have all my scripts. I have my player controller, and last week we made our player controller, right? And notice what we did with our player controller. We had a couple of things. We had a left boundary and a right boundary, right? Because I wanted to check bounds. I wanted to see that the ocean or the player doesn't go to the right or left beyond my right and left. Well, I want to kind of do the same thing with my ocean. I want to check to see that it doesn't go below the bottom boundary, right? And it kind of resets, right? Or it doesn't go beyond the top boundary is what I really want to make. So, so this is kind of something similar we're going to do here. And whenever I do something similar, I always got to think to myself, I'm kind of repeating myself. Is there something I can do to make a class that I could reuse somehow? I don't know yet. Let's see. Well, let's double click on our ocean controller and let's start like this. So this is my ocean controller, right? And what I want to do is this immediately. I want to say, well, okay, so every time my ocean controller, when my game starts off, I don't want to risk somehow that I've messed around and my ocean started with a weird value. So I want to reset my ocean to negative 480, right? I want to reset my ocean to to 480. That's the value. So I'm going to create this private method, right? This private method. Hopefully you guys can see this thing. I don't know if you can. There it is. I can make it bigger. So I've got this private method that I'm going to call reset, and it returns void. So private method that I'm going to call reset, right? I'm using the underscore convention. I know some people don't like that, but it is what it is. So I'm using the underscore method. Now, if you're using Visual Studio, It may look different than what it's looking for me. I'm just using mono behavior, which comes with Unity, okay? But it doesn't really matter. So I'm calling it reset. And in my reset function, what I wanted to do is I want to talk about the position of my ocean. Every time I call the reset function, I want the position of my ocean to go back to a y value of 480. Okay? So in order for me to do that, I need to kind of call the position function. Now the great thing is, if I just say position, right, this doesn't come up. But what if I go transform? So if I go transform, right, lowercase t, dot position, it really talks to the position of the object that this thing is attached to, right? Transform dot position, I'm going to make it so that it is a new. We'll make it, because we're using a 2D graphics, we'll use a vector2 object, right? And I really don't care about the x component of my ocean. The x component of my ocean is always going to be 0, right? Because it's going to be centered on the screen. Go for the x component. And you can see that when I'm typing, I'm getting some code hinting, right? Notice that I'm also listening for floats, floating point numbers, so I've got to put the F next to it. You can leave it out in Unity, but I like to put it in. And then some kind of number, so 480, F, right? Now, this is okay because this is, even though I've put the number in here, and I could have asked for it on the in the panel. How do I do that again? How do I make it so that I can enter values for the ocean? Right? I talked about this last week for people who never took Unity before. Who remembers what to do? I want to make this, I want to expose these values. Instead of hard coding it here, I want to expose values on the inspector. How do I do that? Yeah, I can make a public variable. Oh, I hate that, right? Public variables, when you program, right? In C#, they're like, never use public variables. Public variables are like global variables, the worst ever, right? They're supposed to make public properties. Well, public properties, if you remember how they look in C#, they look like this. You kind of declare two parts, right? The one part, you might have a private instance variable. So we're going to make some comments here. This is how it normally looks. So private instance variables, right? This is how you normally code stuff if you're programming. And the private instance variables are basically a data store. That's what they are. They store the data for the public. They store data for your program, okay? And public properties are kind of the ambassadors of your data, right? The public properties, they are the public face, or the interface, if you will, to store data in your program, right? So private instance variables would look like this. This is a float, right? And then I would call it something like, you know, the position, right? So this is the top position of my screen. So we'll say top position, right? We'll call it top position. And we're not going to use it like this. We're also going to use an underscore. I use underscore to indicate that it's a private instance variable, right? Underscore means private. So if I look at the variable, I instantly know that it's private, right? It's just a way of me doing that, all right? Some people don't like that. It's just my convention. But then I might have a public property. Here's my public properties, right? And my public property, I'm going to do public. I'm going to make the public property capitalized like this, like top position, right? And I'm going to give it a return type, right? So a type for my top position, not top position like this. So it's got to be top position, and the type is going to be the same, float, right? So it's called. There's two. One's private, one's public. And normally, what we need to do is something like this. We need to put these curly braces, and then we need a get. I'm doing this by hand because mono behavior doesn't do it for me. And a set. So there's getters and setters. Okay, that's your public property. All right. Now, a problem. Okay, but let's just talk about this. When I use a getter, right, I want to return. I need to have a return type. I want to return whatever value is stored in top position. So in here, I'm going to say something like return this dot underscore top position. That's what I'm going to return. I'm using the this keyword to indicate that it's the instance variable that belongs to this class or this object, right? And then when I set, this is normal, right? If you're going to program in C#, just regular C#, you would say that this dot underscore position, top position, is equal to a keyword value. And value means whatever I put on the other side of the equal sign, it's going to take and assign to my private instance variable top position. So I only expose this public property, but I store stuff inside my private instance variable. And this goes along with that old object-oriented programming design pattern, which is information hiding. I want to hide the information. I don't want them to be, I don't want my data member, right, my private floating point underscore top position. I don't want it to be exposed. And I want to have control because I have two accessor methods, a getter and a setter, where, by the way, I can put additional stuff in here when I set or get any kind of data, right? Do a debug.log saying, you know, this value has been stored. Okay, so this top position. Now I made it public, and we said that public things should appear on the inspector. But unfortunately, in Unity, I just want to show you this. If I go to the inspector for my ocean controller, see that there is anything public here? The answer is no, right? Actually, and this is a weird thing, even though I've made a public property that should be on the inspector, it doesn't. I can try to expose it by using these other brackets here. I want to show you something here. So under the brackets, right, I can add in different attributes, right, to kind of expose it, right? So if, for example, I want to make it so that it's exposed in the inspector, right? That's what I wanted to do. I want to expose this thing on the inspector. So if you want to see how it works in Unity, if you want to see the scripting, so expose variables. There we go. What you can do, right? And they don't actually show the. It's called serialized field. Yeah, serialized. What you can do is you can use the serialize field, your serialized field attribute like this, right? Even though it's private, you can serialize the field and make it available on the inspector, right? Well, that's for private. Will it work for public properties too? And the answer is probably no. So if I say serialize field, look. So here's my serialized field, and I put it before my public property, and I save it. And I go back to the inspector in Unity. You know, we would hope that it's going to be here. But unfortunately, Unity does not have support out of the box for public properties. And this is why, this is the real long reason why, we use public fields. You can also serialize private fields as well. But we use public fields like this. We make this public so that we can expose them on the inspector. So when we do our game testing, we can put different values in there to see maybe that there's a better value for our objects than the value, a hard-coded value like we're putting here. I'm just putting this in. I can never change this, right? But if I use a field that my user or me can play with, I can adjust where that thing is. Now, in this case, the ocean, it's going to be a fixed value, so it's okay. But the way to expose this would be to make this public. That's one. I can do that with public. And I can change this to top position. And I can get rid of all this stuff, right? That's what I'm supposed to do, right? Make it public. Okay, let's get rid of this for a second. So that's one way I could do it. And if I go back, right? And if I click away and click back to my ocean, you can see now that it's exposed on my inspector, right? I got 0 value. And I can put in a number like 480, right? And that's totally cool, right? The other way to do it is to make it private, like we said, and then expose the field by calling the serialized field attribute, right? And if I do that again, and if I click away and click back, we should still see it on the inspector, right? So now we've done a couple things. One, it's private, but we have access directly to my private instance variable here, right? So I don't know, I'm more comfortable with making it private because my top position shouldn't be exposed to my class, let's just say. So I can leave it like that. And what I can do is just keep that whole idea of private instance variables. I don't like it, but this is the Unity way. Okay, there are other ways to do it with getters and setters. For now, this would be the easiest way for you guys to do this. Okay, cool. So now that I have something called top position, I can use it instead of a hard-coded value down here. So I can say this dot top position, right? So that's what it's going to be. So when I reset, I'm going to change the position of my transform, my position component. This is my property of my transform component. Here's my transform component. Remember I told you all game objects in Unity have one thing in common, the transform component. If I ever ask you on a test, anything to do a little bit of a quiz, it's going to show every game object has a transform component. Remember, game objects in Unity are an amalgam, or they're all component based. Let's put it that way, right? So I have, in this particular case, 1, 2, 3, let's say 4, one component that you can't touch. But let's say 3 components that are part of this Unity sprite, this ocean sprite. And if I look at the player sprite, we also have 1, 2, 3 components. In this particular case, the main camera has 1, 2, 3, 4, 5 components. But all components, all game objects have this transform component, because the transform component really defines a game object's location, rotation, and scale. Okay, those 3 things. In this case, they just call it position. So if I look at the ocean object, it has position, rotation, and scale. And I need to access the transform component. So inside my script, if I go back to monodevelop, I'm accessing the transform component, and I'm looking at the position property, right? And what I know is that the position property, when I hover over it, either takes a vector 3 or vector 2. That's what it is. Notice it is a property. It has a getter setter, right? In this particular case, this transform position. Okay, so how come I can assign a vector 2 object to a vector 3 property? How can I do that? Because this might, if you, in C#, if you saw this, you'd be like, hold on. It needs a vector 3. That's what it says. But I'm giving it a vector 2. How come that's okay? What is a vector 2 and what's a vector 3 anyway? Anyone understand that? Anyone get, kind of can define or intuit what that would be? Okay, vector 2 is x and y, right? And vector 3 is x, y, and z, right? I'm listening for a vector 3, x, y, and z, but I'm only giving it a vector 2, x and y. What happens to z? Automatically 0. And that's what they do in Unity. It's an overload. So it says, well, if it's expecting a vector 3, both a vector 2 and a vector 3 come from the same superclass, right? They're both the same kind of class or object that I'm creating, right? And if I give it a vector 2, if a vector 3 gets a vector 2 object, it just assumes that the z component is 0. That's what happens, okay? Now, in C++, if you're programming OpenGL with C++, you would get a big error here, because you would have to put in, because C++ is very unforgiving, right? And so is Objective-C and all these other older languages, right? And if you put something like this, there's no overload that can save you here, right? In C#, though, we have some flexibility, and that's why Unity uses C# as well, where you can program it so that it'll accept vector 2 as an object, right, and convert the z component to 0. All right, so that's what we're getting here. So I can use a vector 2, and it's okay to use vector 2 in 2D games because we don't really care about the z component, right? We're making a 2D game here. I'm just going into details in the weeds so you understand why I'm doing the things I'm doing. All right, so this reset method, I need to call it, and I'm going to call it as soon as I start the game. So I'm going to call it like this. I'm going to say in my start method, in my initialization phase, I'm going to call reset. All right, so I'm going to call the reset method, right, which resets my position of my ocean to the top of the screen. Let's test this notion, all right? I'm going to move my ocean, right, just so we can see that it's not at the top of the screen. I'm going to move it so that it's halfway down, right? Now, normally we would see this halfway split. If I went to my game, you'd see something like this, right? If I started it. So if my script works, we won't see this. We will see a full screen of ocean, just to test it out. So if I press play, we should see a full screen of ocean, right? So that means it's moved to the proper position. And for you to change it, to check it, when in gameplay, what you can do is, even though this thing shows it's playing on the top here, see, on the top, you see it's playing. I'm in play mode. I'm in real-time play mode, I can still modify my transform, all my values here on the right. So look at my position. I can make this something weird, like, I don't know, let's make it negative 900. You can see now that the position, I can change it in real time to test the value, what it would look like in gameplay, right? I can do that, right? If I stop playing, it'll go back to where it was before, right? Let's put this back to 480 where it belongs. All right, so I know that it's resetting. I know that, and that's the first thing. So what I'm doing is I'm trying to diagnose and confirm that my code, my script, is going to do exactly what I want it to do, right? Don't assume anything with programming, right? Make sure that it's going to happen the way it's supposed to happen. And I'm doing it in little parts for you guys to see this. And this is going to help us when we make other prefabs today. Okay, so this is the one part. You can see that I've got this stuff going. It's resetting. Now I want my ocean position to change every frame. So every time remember, if we can assume that Unity is operating at 60 frames per second, let's just assume, right? Then every frame I want it to move the ocean downward, right? I want to move the ocean downward, let's say a certain number of pixels, right? And let's assume that we're going to move the speed of the ocean moving downward is around 5 pixels per frame. 5 pixels per frame times 60 frames per second is approximately 180 pixels every second. It's going to move down. We have 480 pixels of height, so it's going to take a couple of seconds for the ocean that one screen of ocean to disappear and then for it to reset. It's probably going to take about 6 seconds for the whole, or 7 seconds for the whole thing to reset. That's what it should take, right? So I want to move the ocean down. So that means I need some kind of other instance variable up here to kind of hold my speed. I'm just going to keep up this whole idea of private instance variables instead of public. And let me see if it actually shows up. Do I have to do serialized field every time, or do I have to just do it once? Let's see. So if I say private, and I want to move it, I want to make a float, and I want to kind of talk about the speed of the ocean, but the speed across the y-axis, right? It's almost like our vertical speed, right? So I'll just call it vertical speed. Vertical speed, right? I'm not going to assign a value for it immediately. I'm just going to call vertical speed. I'm not going to initialize anything. But what I want to say is every frame, and I do this in the update method because the update method is called once per frame, right? Every frame, that's every 16 milliseconds. If we assume that this is 60 frames, it's going to refresh the screen or redraw the screen 60 frames every second. Every 16 milliseconds is going to call that update function, right? And inside my update function, I want it to move. I want to move my transform position, right, down. I want to move it down by a certain value, whatever that value is. And we can change the value. So I'm going to do the same thing. I'm going to say, well, my transform dot position, right? What it's going to be is a new vector2 object, right? And I don't care about the x coordinate, so I'm going to still leave it at 0f. But here's this is the challenge. What do I put in here? If I put speed, well, that means that speed is going to take me to that exact position every frame. I don't want that. I want to add my speed to my current position. Okay, so let's use another variable. I'm going to make another variable. I'm going to use var for now. I'm going to create another variable called current position, just to make it clear, right? Is equal to the transform dot position, right? Transform dot position. And what I want to do actually is my current position, I want to only care about the y value. I can read a floating point y value, vertical value of where my ocean is. Okay, that is my current position. Okay, so I read it in, and if I hover over this thing, it tells me that, well, current position, because I'm getting a y value, and a y value is a float. Well, then current position should be a floating point variable. Let's change this to float, because that's the real value. So float, current position, transform dot position y. I want to take that, and what I want to do is I want to add my speed, right? I want to add this dot vertical speed. That's my new position. That's my current position. I want to take this current position and add vertical speed to it, right? Well, if it's current position and I'm adding vertical speed. That's not my current position. That's my new position. So let's rename this to make it more contextual. My new position is my transform position, my current position. That's what this is, plus my vertical speed. And I'm going to put this in my new vector2 object. And you may want to name this even better than this, because new position means, hey, wait a minute, what about my x component? So new vertical position, you may want to make a much bigger variable. By the way, we can make our variables as big as we want. So if I say new vertical position here, I just make it really super clear what's happening for you guys, right? I probably wouldn't name this so long in real life, but just to make sure that you understand. So here's new vertical position. We're going to put that right in here, right? And what's going to happen is every frame, it's going to calculate my new vertical position, and it's going to create a new vector2 object, instantiate a new vector2 object, and take my new vector2 position, right, and assign it to the position. I can't directly change the y component in Unity. I can't sit there and go, well, transform position.y is equal to transform position.y plus this vertical speed. I can't do that like you think you might. Okay, I can't do this thing. But I can assign a new vector2 object as a reference to the position property. Okay, so this should move us down a certain speed. Okay, now to test this, first of all, let's see, does the ocean expose my new position? Well, no, because if you notice at the top of my code here, I did not serialize my field. In fact, I need to serialize every field, right, that I want to expose on the inspector. So what I could do, just to make it easy for myself, is in front of my private variable, I could put this serialized field, right? I could put my serialized field attribute, right, so that my variable is exposed in the inspector. And let's see how that works, right? So I kind of click away, and you can see vertical speed now is exposed. And I want to put a vertical speed of 5 pixels per frame. Let's see if that's good enough. All right, so the ocean, if I did it right, should scroll down 5 pixels per frame. Let's see if that works. We're still not done yet. Oh, whoa, what the hell happened? Where'd it go? How come it went up and not down? 5 pixels per frame, I thought vertical position, but actually what I made it do was totally something wrong, right? Well, it makes sense because look what I've asked to do. I said go from 480 in the first, in my first frame, it would go from 480 to 485, right? And from 485, it would go to 490. Let's keep on scrolling up. So I went to 490. And I keep going, and I keep going, and I keep going. You can see that the ocean keeps rising forever, right? And that's not what I want, right? I want it to go the other way. I want it to go this way, right? So it's actually, I want to subtract it instead of adding it. So go back to my code. I don't change this part, right? I want to change this part. So where it says plus, I'm going to say minus. And that, my friend, should make my ocean start scrolling down. Let's see if that works. I run it, and now it starts scrolling down. Now I get a bit of a delay because I'm doing it in my in the simulator. Oh man, what happened now? What the hell happened? Right? How come it did that? Let's try it again. Oh man, what the heck? Why is it moving like this? It's moving slow, and then oh. Well, of course it's going to do that because let's see what's happening on the game. Now, the good thing is this, right? Once I press play, I can also press pause right away. So I can pause my ocean. Now, look what it's done. It's actually moved the ocean down programmatically. And I can see that what the scene looks like and what my game looks like. I can pause the action. If I unpause and if I look at my scene, I can see what's happening here. My ocean is moving down 5 pixels per frame. And then, well, it keeps moving down forever, right? I haven't told it to do anything, and C# is going to do exactly what I've told it to do, which is keep moving the ocean down forever. Okay. I need to reset it again. So when it comes to the top, when it comes to a certain position, right, I want to reset my ocean to the top again. And I got to figure out when that position is. I got to check where my position, when my ocean hits the top boundary, right? Then I know that that's the case. And I know, remember, it's going to be a minus 480. So when my ocean position or my transformed position component when it hits negative 480, I know that I must reset it to 480 again. So in my code, and I'm going to share this code with you in a second. In my code, if you look, I've got my top position and my vertical position, right? My top position, vertical position. And I want to know when it comes to, when my ocean gets to the boundary, my top boundary, let's serialize that one too. So I'll call it top boundary. So I'll say serialize field, right? Private, and we'll say float, we'll call it top boundary, right? When my ocean hits the top boundary, then we know it's a problem. And I can check for that in my update function, right? I can say something like this, right? I want to call a method called check top boundary or check bounds. Let's just call it check bounds. Check bounds. And we'll make it in a private method again, so we'll say check bounds. We don't have this yet, but we'll make it. We'll say, hey, every time we move the ocean down, check bounds to make sure that we haven't hit our top boundary yet, okay? And let's make another private method down here. So we'll say void check bounds. We're going to say something like this. Inside here, we're going to make the check happen. We're going to say if, right? This dot, sorry, we'll say transform dot position dot y. We can check that. We can use it to, we can read from it, but we can't write to it, right? If my y position is greater than now, or sorry, less than or equal to the top bounds, the top boundary, right? We know that we need to reset it, right? And we're going to call the reset method that we already have. This dot underscore, then call reset. All right, so this is the reset method. This is the this check bounds, right? And this what this does. This is reset. So let's write some comments. In C#, if you write the triple forward slash, right? What it does is it allows you to write little comments, right? So this is what it says, checks the bounds, right? Look what it does automatically. In Unity, kind of gives me a little bit of a summary, checks the bounds, checks if the ocean reaches the top boundary, right, of the screen. Then calls the reset method, right? You know what the reset method does. And the reset method, we can do the same thing. I can do triple forward slash here. So 1, 2, 3. Triple forward slash, it'll say something. It doesn't say reset this instance, right? It'll say reset the vertical position of the ocean object to the top position. We can also, instead of top position, you could have used the reset position. You can use whatever other variables you want here, all right? All right, so we've got a couple of comments here that I put in, and let's see if this works now. If I save this, right, and if I test it, it should provide us a continuously scrolling ocean for an ever and ever, and we shouldn't see a problem. Let's see how this works. Oh, that was weird. See that? Oh. Oh. What the heck? What's going on? It's not perfect, is it? How do I fix that? And can I fix it? Well, let's look at the scene and see what's really happening. So it's coming down to here, and then that's not what I wanted. What the heck is happening? Oh. It's going to 0, right? Why? Because my top boundary, my friends, I didn't change in my inspector, right? I've left it, and unless I initialize my inspector to some value, it's going to assume that the top boundary floating point number is 0. So let's make it so the top boundary is negative 480. Okay. Let's try it again. If I try it, maybe it'll work. It's not so bad. It looks slow, but remember, I'm running it I'm running into a performance problem on my machine because I'm broadcasting live on the internet. I'm doing Unity at the same time, right? Lots of stuff are going on with my machine. So how do I test this to see the real performance? You can see the slowdown I'm getting. Well, what I want to do, instead of writing it here in the simulator, that's what this thing is, I want to run this thing, right? I want to build it and put it on the web, right? So I want to check my build. Whenever I add a new feature, I always want to check to see that that feature works, right? So I'm going to do that. I'm going to say File, Build and Run. I already have my build settings figured out from last week. So all this should do is do the whole build and run sequence, which should populate this in a WebGL format, right? So I can actually look at it. And I'm going to show you guys, maybe not this week, but maybe next week, how to create a GitHub Pages kind of site, which is free for your team, where you can kind of show your game live on GitHub, right? It used to be able to be done. Hopefully, they'll still give us access to do that, right? But anyway, so if you notice, this is doing that whole build thing. And once the build is done, guess what I'm going to do? I'm going to put all this up on GitHub for you guys, right? So you see the build, you can look at the code, and all that kind of stuff. Now, after this, because now we've done about an hour of me talking, right? From 8:30 to 9:30 for people who straggled in and late, right? We're going to get right into presentations. So after this, we're going to take a short break. You can organize yourselves into teams, whoever's here, and then I'm going to pick randomly which ones are going to present, and you're going to present your pitch. Okay. Now remember that I'm also going to provide a Dropbox for you, so when you're done your pitch, you're going to load up your PowerPoint presentation so I can review it later on. Okay, that's going to be one of your requirements for today, and it'll be due by midnight tonight. The design document is something we're going to be talking about. Yeah, but you should have your design document, at least in first draft, also due today, right? So I'm making it due by midnight. So if there's anything you're going to take from this, if you take any feedback, then you can use that feedback to improve your design document. Okay, here's my stuff. Now take a look at the performance, right? It's a little better, right? Because I'm not running in a simulator anymore. I'm running it right on the web. So I'm using WebGL. That's my target. And you can see now that it looks like my plane is flying over the ocean, kind of, right? Here's a challenge. What if I press this full screen thing? Okay, I'm not going to press it, but you can try it. You're going to see these bars on the side of my plane here, which is going to basically show that it's not going to take the full screen. It's going to look weird. But if you see this, like, it doesn't look like there's a seam. But really watch carefully. Watch. Can you see the seam? Well, oh, right? There it is. And it's so slight, but it's still not perfect. And that's why I told you this graphic, although it's not bad, is not a perfect graphic for you to make a scrolling background. So for those people who are making a 2D shooter, remember I've asked you to make it scroll somehow. You need to find a proper tiled background. That's what they're called, right? And you can find them online. You can also create one where the ends of your background match. So if I have a background that starts, on my left and it goes to my right, then my left border and my right border match each other somehow. So they look like it's a continuous scrolling background. And the way to do that is if you have a mountain, if you're doing a right-left scroll, right, and you have a mountain that kind of draws up and down, you're going to try and bring it down towards the bottom, right? And so that it's at the bottom here, and then it's going to go up again, right? So it's going to look like there's another mountain, right? But it's really not another mountain. It's like there's just something. Now, the best scrolling backgrounds are quite long, okay? You don't want to make the scrolling background, and this is, by the way, a single scrolling background. You can have something called parallax scrolling, where you have multiple backgrounds scrolling at different speeds, layered one on top of the other, right? To produce that layered or parallax kind of scrolling background effect, which makes it look like 3D when it's actually 2D, right? Or some kind of weird parallax scroll. Okay, so we've done this. Great. I want to put it up on GitHub over here. What do I need to do next? So I've got this game. So far I've got two things. I got my ocean and I got my player, and I want to put it up on GitHub. Can I just go on and put it up on GitHub? Do you recommend me just going and put it up on GitHub right now? What should I do? What should I do? I got to save everything. I got to save my scene. I'm going to save my project. I'm going to close off Unity, right? Because unfortunately, Unity doesn't talk nicely with GitHub, right? I'm going to go into my terminal window or command prompt, Session restored. Yay. I'm going to go into my command prompt, right? If you're a PC guy or if you're a Mac, it doesn't matter. And I'm going to go into my folder for my Unity, right? So this is my folder. Let me go back out one. Oops. And what I want to do is I want to drag and drop. I want to do something. Let me just clear the screen here so you can see. I want to do CD. This works on Mac and Windows. CD space. And I want to drag and drop the name of my folder for my game onto my terminal window, right? And press enter. And that's going to take me, whether you're a Mac or a Windows machine, right into the folder that you want to put up on GitHub, okay? And then I'm going to say git add dot. Git add dot, basically what it says is, hey, take all the files that are inside of my project and put it onto the staging area. Mark all these ones as files that I'm going to put into my up on GitHub. Okay, now I'm going to make a little commit message. A commit message, remember, was a snapshot. It takes a snapshot of my files, right? That's the next part. So git commit -m, and I'm going to say added ocean object. That's what I did, right? And so it adds that in, and all this stuff happens, right? It adds and deletes certain things. You can see that there's some caching it's taken away because, and I wouldn't have got some of this. Sorry about the screen. I wouldn't have got some of this if it wasn't for me closing off Unity. That's why I need to close off Unity, because it does all this funky stuff, right? Is that clear? You don't have to see that. And then my last one is git push. So git add, git commit, and this last one is git push to my origin remote into my master branch up on GitHub, right? So origin is the name of my remote, the connection between my local repository and my repository on the cloud. And my master branch is the place where I'm going to store my files up on GitHub. And that's the default, right? You can have many branches. If I press enter, and it knows who I am, it's going to start pushing everything up to GitHub. Now remember, I also have my build folder attached to this right now. And it says, uh-oh, I'm giving you, Tom, you're going to get a warning here because you're putting some bigger files, right, up on GitHub. Remember how big it was, right? Now my build is like 82 megs, right? Like it says, it's like I've got 82 megs happening. This is larger than GitHub's recommended file size of 50 megs, right? You can look at this. There's some stuff here. Did it do it? It still did it, but you can see that there is a information that says, warning, you know, we've got some problems, right? And that's why we don't normally put my whole build up on GitHub, typically, all right? You can put your build up on GitHub, but once you have build files that are larger than a certain number, you don't want them up. And the build files that are associated with GitHub are created by Unity, all right? Let me show you these files really quickly. I have a builds folder that I created, right? Here's my builds folder. And in my builds folder, I have a WebGL folder. That's where I'm getting everything. And notice that I've got a couple of things here. I've got template data. This is all the template data stuff that comes with Unity by default, right? This isn't very big here, as you can see, right? But inside my build, right, we have a Unity loader.js file that converts from C# to JavaScript. And where the heck is my big file? I don't see it. Do you see a big file here? That's 80 megs. Right, look, I got 150K, 2.3 megs, 87K, 221K, 1.5 megs. What the heck are they talking about? Right, well, it's not in here, guys. Right, I can put my build folder up on GitHub, no problem. It's that I have additional data, right, that you guys can't see here because I'm looking at 50 megs or something like that. Where's my 50 megs? Where's my 87 megs? Where is that? It's not here. So where would it be? It's either hidden. Those are two possibilities. It's either hidden or it's not even here at all. It's somewhere in my project. Somewhere in my project. Let's look at the object file. This is my object debug file. This is almost like a garbage file that it creates. So if there's anything in my debug folder, it's got object files that Visual Studio or MonoDevelop creates. How about my library? That's pretty, that might be pretty large, right? Really, look, they're pretty small files too, right? Hold on, I'm getting there. You guys are killing me, right? I'm doing a demo here, man. Don't steal my thunder, right? All right, here's my project settings, right? In my project settings, right, I've got my files. Let's look for some big files in my project settings, 580 bytes. I don't see big files. Well, there's a bunch of other folders, but that's not them. That's not nothing to do with my project settings, right? It's a bunch of documents. So what the heck? Where is it? Where is this big, massive file that they're talking about that I have that's like really big? I don't see it. Not in my assets, is it? Couldn't be in my assets. I mean, assets are small. Look, they're like 56K. My whole project, if I was to right-click on my project itself and go get info on a Mac, right? Man, I mean, how big is this thing? Whoa, 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 wait a minute. What the heck? How come my project is 353.8 megs? Where the hell is my files? What makes it so large? I'm only using like really small items. My sprites are minuscule in terms of size. You saw, they're like, my ocean graphic is like 588K, right? Where the heck is this 500 or 353 megs coming from, right? That's huge. Help me out. Where would it be? It's not in my debug folder. It's not in my library, right? Let's make this wider so you can see, right? It's not in my library. So what is GitHub complaining? Where the hell is it? How about script assemblies? Oh. Whoa, okay. That's pretty small. It's not in there. I thought it was there. All right, let's keep going. Here's my WebGL cache, right? WebGL cache. Well, I don't see it. Oh, there's 1.3 megs, but that's it. There's nothing big. What? Where? Where's the 10 meg? Oh, but that can't be 300 megs, right? Where the heck is it? Where is this stuff hiding my assets? Here's my IL2 CPP cache. What's CPP? C++. In the background, even though we're programming with C#, Unity is programming with C++ because it's accessing my OpenGL. It's using OpenGL to access my video card, right, on the Mac. That's what it's doing, right? So here's my CPP cache. Maybe it's in here. Well, this is just caching files. Here's my link results. Oh, look at this bastard. Look right here what we got here. Woo! My build.bc, right, that's inside my library, look at this, right, is massive. It's 86.4 megs, right? That's big, and it's one big file of 86.4 megs. That's what GitHub was complaining about. This, my friends, is a garbage file. We don't really need this one to go up on GitHub, right? We would generate this one again if we ever ran our build process, right? Or if we ever run it locally. So this whole library under IL2 CPP underscore cache, we want this library to be removed. This whole part, this whole folder to be removed from GitHub, right? Because I don't need it. It's all cache anyway. Cache means it's being written once. These are garbage files that are being generated by Unity, right? And that's one. Let me keep going here. So other big files, there's other caches here, right? Maybe there's another big file that's in here that I missed, right? That's massive. And it doesn't take long to figure this out, right? But you should really inspect your files to take a look. And by the way, just as a reminder, we're only using Unity 2D. God help you if you download assets for Unity 3D. Like I said, it could be as big as, I'm not joking around, I had a project that was 12 gig, right? For a very, very small, simple first-person shooter, right? That we made. So why? Because we have all these assets, and you know you don't need all of them, but they combine them into the Unity project. Like, look, there's a ton of little files here, and all these garbage files went up to GitHub. I don't need this on GitHub. GitHub is to protect your project folder. So if you do code changes, it'll keep track of that stuff. This? It doesn't need cache files. How about this? How about this global cache? Maybe there's some more files in there. Hopefully not, right? So this part, definitely not. These parts, because it's WebGL cached, again, WebGL cache, it's cache, right? These are all cached, right? And if I look where all this stuff is, right? Just to show you, it's inside these folders, right? Inside of my library. So anything that has these two files, IL2 CPP cache, WebGL underscore cache, these two folders absolutely should not be on GitHub. Doesn't make any sense. How about all this stuff? Logs, Unity shader logs. They're just log files, right? So probably anything with a .log right? Anything with a with an underscore cache, any folder with an underscore cache should be in something called a gitignore file. Git allows you these special files called gitignore files where you can specify, hey, Git, I don't want you to put this stuff up on GitHub. I want you to remove all this stuff from Git. I don't want you to include it, which will make our GitHub process a lot smoother, right? I'm just pointing this out to you so you know what to look for. Some stuff you have no choice but to put up on GitHub, like script assemblies. I mean, even this stuff is probably not required. In fact, most of the stuff that's inside this library folder probably wouldn't be required. But these two for sure should be out, and all these log files, you don't need them. In my object files, there's nothing inside there right now. My project settings you definitely want up on GitHub because these tell you how I've managed my assets, all the assets that I've got in there, my input manager, my nav mesh areas. I want that up on GitHub, right? All my stuff in my assets folders, as long as you're using it, I gotta specify here, all right? What if I download, like I said, 12 gigs of assets to make my game, but my build is only like 50 megs? I don't use it all. It's just inside my project, right? So I can drag and drop whatever I want. I don't want to put all my assets up. And so sometimes what I do is I create another folder inside my assets folder that says something like imported assets. All those imported assets, I don't want them in my game, right? So I kind of exclude those to put up on GitHub as well because those are imported assets, things that I'm using to build up my game, right? So I definitely don't put all these up there, right? Only my own assets I put up, right? And the builds folder is not that big. If I right click and go get info on my builds folder, you can see that it's 4.3 megs. So my whole game, even though it's 353 megs because of all the caching and everything else, it's really only 4 megs, which makes sense because it's just a web game. That's all I've made, a web game that's about 4 megs, right? I'm showing you this stuff because when you build your game for this class, right, you know, the behavior, the default behavior that us as students, you know, we kind of do is just put everything up on GitHub. But it might give you problems. It might even stop you. When you go beyond 100 megs, your GitHub will stop. It won't even work anymore. It'll say like, man, error. It doesn't. You're not able to put this stuff up because it's larger than the biggest capacity, which is about 100 megs actually. And it's going to happen to us soon. Any questions around this stuff? So we talked about just before I stop recording. So I need to stop recording now so you guys can get to your presentations. So we talked about a couple things in this class so far, right? We've talked about. I'm just going to bring up Unity for a second. In Unity, we talked about some more scripting information, stuff that we maybe you didn't cover in your last class with Unity. If you did have a class with Unity before, like for example in that COMP301 Intro to Game and Simulations class, if you took that, maybe this wasn't covered there. Or maybe if you're not a gaming student, don't check for updates every time. If you're not a gaming student, then you've never covered this before. So this is all new to you, right? And so we covered the idea that each object that I want to control, I want movement controls on my object, must have a script attached to it. And I have two, one for the ocean and one for the player. I need one script for each object, right? I've covered that. And when I talked about my ocean controller, I also talked about the need for us to serialize fields if they're private. In my player controller, I made them public. Right? So they're immediately serialized or shown inside my inspector. But sometimes, and quite often a lot of times, we want to make the fields that are inside of our class private, right? But we can still expose them on the inspector, right? That's what we want to try and do. So that's what we talked about today so far, right? So any other questions around that? So right now we're sitting at 9:48. I'm going to give you guys 12 minutes to put your stuff together. Maybe a little break to go to the washroom and all that kind of stuff. And then I want to see which teams are ready, and we're going to start the presentations. I'm not going to record the presentations because I'm just recording myself here for you guys, right? But I want to get yourself organized. And remember, you're going to do a pitch. I'm looking for a PowerPoint presentation, right? That's what I'm looking for. So hopefully you all have that, right? Because I talked about slides in the requirements, right? And that you're going to basically talk about your game. I don't want it to be more than 5 to 7 minutes. If you don't over talk a slide, don't sit there and keep talking about a slide. If the slide doesn't talk to me, it's wrong. Something's wrong with that slide, right? And if there's too many words on the slide, something's wrong with that slide. It shouldn't be a lot of words. Remember, it's a visual language, right? I want you to, I should be able to look at the game, the slide, and go, oh, yeah, I know what the game they're making. Okay, so let's take, actually, let's say we'll take it to 10 past 10 to give you guys a little bit of time to get coffee and stuff too.